In the last class, we saw how we take analog output from the Arduino. Today, we will see how we give analog input. Analog input is given at these pins from A0 to A5. All these pins are analog inputs, and these are very important because most of the sensors are analog and they are used at these pins. So for sensor, these pins are very important. We can now see how we use this pin. For that, we take a potentiometer, place it here. A potentiometer is a variable resistor. When we move this, its resistance changes. It has three legs: terminal 1, terminal 2, and the center leg is called wiper. Okay, terminal, we connect terminals to supply. Supply means 5 volt and ground. You can connect any terminal to 5 volt and any terminal to ground. Okay, I connected terminal 1 to 5 volt and this one is connected to ground. And the wiper is connected at analog pins. You can connect any one of to any one of these pins. Let's say I select 4. Okay, so this is the circuit, and now let's try the program. I will try to keep it very simple. Void setup. Only one line inside setup. Serial dot begin at 9600. Okay, and void loop. Inside the loop, we will read this pin. We will read A0. Okay, so serial dot println analog read A0. We use this command to read analog pins. Analog read, then A0, A1, A2, A3, any pin. Okay, let's now give a delay. Let's say 500, and that's it. Now what happens when we change its resistance? It will change the voltage at A0. This voltage will be converted to a number and it will be displayed on the serial monitor. Okay, this is his serial monitor. Open it. Now let's start. Okay, now see, it is giving 1023. It means it is 5 volt. When I change it, this number will change. Now see, it is changing. And it is 0 here. That means if it is here, we have 5 volt at A0. And when we move it here, there is 0 volt. So 0 means 0 volt. 1023 means 5 volts. And similarly, half of 1023 is approximately 512, and it will mean 2.5 volt. If you find out what is the voltage, you can use this formula, 5 over 1023 into that number. Now let's say I move it and I want to know what is the voltage. Okay, let's say it is 384. I will just write the number here, 384, and I will calculate the voltage. Okay, 5 divided by 1023 and then multiplied by 384. Okay, so this is 1.8 volts or you can say it is 1.9 volts. 384. Similarly, you can calculate the voltage of any number, but main point is when we change the resistance, this changes the voltage at this pin, and we read that number, or we can print that number on the serial monitor. Similarly, in the same manner, we use sensors. Let's use a sensor. Okay, for that, just type here temperature, and you will get this temperature sensor. Place it here. Okay, now see, it is same as potentiometer. It also has 3 legs, and it will work in the same way. Okay, delete this one, and now see, it spins. One is power. Power means 5 volt. It will be connected to 5 volt. Okay, connected here. And this one is V out. It will be connected to A0. And this one is ground. It will be grounded. Okay. Okay, now similarly, when temperature changes, resistance of this device changes. When resistance changes, voltage at A0 will change, and when voltage here change, number on the serial monitor will change, and from that number we detect what is the temperature. Okay, let's see. Okay, start. Okay, now the number is 153, and if we change the temperature, we decrease the temperature, number is 20. Now we are increasing, number is changing, and when it is 125, number is 358. So notice that it is not necessary that number for all the sensor will change from 0 to 1023. There could be a range like this, from 20 to 358. Okay, now let's say we want to design a temperature sensor. If temperature goes above 50 degree, an alarm should ring. Okay, for that note down the number when temperature is 50. Okay, decrease it. All right, it is 50 and temperature is number is 207. Note it down. Okay, now stop and take a buzzer right here. Buzzer, place it here. Okay, flip it ground, and this will be connected to 10, let's say, or you can connect it to any pin. Alright, now we have to write a program. If temperature goes above 50, this alarm should ring. Okay, so here I will put an if statement. If analog read A0 is greater than 207, that means if temperature is above 50, then we ring the buzzer. For that we use the instruction or command tone at 10, because it is connected at 10, so tone at 10, and then we give a frequency. Let's say I give 1000. So changing this frequency will change the sound of the buzzer. 1000 is a good frequency, you can use this one. Okay, and if temperature is below, we write else no tone at 10. That means buzzer will stop. So if temperature goes above 50, ring it. If it is less, then there will be no tone, no sound. Okay, now let's run it. Okay, now I am increasing the temperature, and when now see, it is above 50, alarm rings. When it is below 50, alarm stops. So this is how we use analog inputs and how we use analog sensors